Good morning, everyone. Thank you for joining us today. This webinar is part of the 3D printing housing hack organized by LafargeHolcim with its partners. Today, you will see an inspiring talk which aims to open up your creativity. After this talk, you will have a Q&A session with the speaker. As you can see, there is a chat on the right-hand side, so don't hesitate to post your questions during the session. Our speaker will answer them at the end. Now I'll hand over to Mihaela from LafargeHolcim, who will give you a bit of context and introduce the rationale behind the event.
Thank you, Adelaide. Hello, everyone, and I'm really happy you joined this inspirational webinar for the 3D printing housing hack. So we all know that the construction industry lacks of productivity, and at LafargeHolcim, we consider concrete 3D printing as an opportunity to revolutionize construction, to make it more sustainable by saving materials and improving the efficiency of construction. So that's why we decided to organize this hackathon, and we really hope to have your brilliant ideas on the topic. So as you know, there will be different phases of this competition. So the aim is to revisit housing design with 3D printing technology, and that will combine conceptual design, but also prototyping. So we will start to work on the topic in the hackathon phase between the 13th and the 15th of November. But before that, today's webinar, actually, it's part of the first phase that aims at inspiring you and giving you insights to push the boundaries of your creativity and to have your innovative ideas. These webinars are made by industry experts, and today we have the chance to have Henrik and Zaid from Cobot International, which is also our partner for live demos in March. They will present actually a state-of-the-art of 3D printing construction globally and also 3D printing design guidelines. So Henrik, Zaid, it's your turn. The floor is yours.
Thank you. So I'm Henrik. I'm the founder and general manager of Cobot in Denmark. I'm the business person. So first you will hear more like business type presentation, and then Saeed, who is sitting here next to me, our architect, is coming on to give you some architectural inspiration. Are we sharing the screen?
Check.
Right. So here we go. The first thing that we will address is why is this interesting at all? And in essence, we're speaking about five main advantages. The first one, which probably will interest you the most, is the design freedom, that basically complexity is for free. If you look at the picture on the right-hand side, you will see the printing of the Bot building, which was Europe's first 3D printed building. And in essence, there are no straight walls in this building. And that was part of the design, which we deliberately did to show the possibilities of 3D construction printing. Because for the printer, it does not matter whether you print straight line or angles or round curves. It really doesn't care. And it will go as fast whether you print one thing or the other. So design freedom is one of the main advantages. Then for, let's say, the more business type people, it's the automation that is the most important, because that leads to lower cost, higher productivity, zero mistakes, better safety, and more precision, which from an economic point of view is really interesting. Similarly, a lot of the construction companies are very interested in this advantage, which is the faster completion time. We simply can print bloody quick, and I'll show you a few examples of that later on. We're not there yet. We are not mastering it fully yet, but we are really improving, and the speed of improvement is impressive. Then, of course, from a CO2 point of view, it's also interesting that when you build this way, where you build the whole thing up from the ground, you don't use standard elements that you cut away to fit in size and so on, you will see an automatic reduction in waste. And then finally, there is a possibility, because this is a new technology, to also apply new materials. Why not start using much more recycled materials as part of the building industry? If you look at the world, approximately 40% of all waste is generated by construction and demolition activity. A lot of this waste could actually be recycled into new buildings. So we are definitely for doing that. Now, when you're not so clever, you have to ask other people. So here's what Deloitte, one of the big consulting companies, are saying about this technology. They're saying it's faster, 50 to 70% fat reduction in construction time. It's cheaper, 50 to 80% lower labor cost, less waste, and a lower financing cost. And it's better because you can customize it. You can make these intricate designs, design freedom, and so on and so forth. Now, do we as Cobot believe this is the truth today? The answer is no, we don't. This is what we are hoping to achieve. We are not there yet. We are showing that, yes, potentially we can go there, maybe especially for the faster and better, for the cheaper. We are cheaper, but not as much as indicated here. That will take longer time to realize. So it's important to understand that this is a technology that is really developing, and we need all the best resources thrown in to develop the technology and the processes around it as much as possible, which is one of the things that makes it very interesting for us to talk to you young architectural students, because you can help change the world. Now, this thing that we are not fully there, where Deloitte is saying that the potential has a lot to do with how it was when you first learned to ride a bike, if you remember. Actually, the first time your parents tried to teach you how to ride a bike, you would probably be falling more than actually riding. And that was the same thing. When we printed Europe's first 3D printed building, it actually took 2 months to do it. Now, the second time you were driving the bike, you had a better idea about it. You were still insecure, you were falling less, but you were riding more. And that was the same thing. We actually made a copy print of that same building one more time, 2 years after, and we improved the speed from 2 months to just 28 hours. Now, by the fifth time you were riding, you actually were mainly riding and not falling that much. So now things were going much better. And that, in our terms, would equate to that we could do the BOT building, which is a 50 square meter building, in around 8 to 10 hours. And by the 10th time, you were riding fast. And that, translated to our business, would mean that, yeah, we could see that in the future, we could do a BOT building with 50 square meters in just 4 or 5 hours. Now, if you look at a little bit more detail, we can show you the video of how the printing of the first building looked like. This is back in 2017. And typically for us, we did it in full publicity. So we had live television cameras rolling while we were printing initially. And you see the building coming up here. At that point, we were called 3D Printhus, and now we are called Cobot. Here you see the final building, still standing. It's a small office hotel. Now, when we took upon it ourselves to do it one more time, we actually decided, let's just prove how much we have improved, and let's do it again. So here you see the print the second time. And again, typically for us, you see a timer at the bottom of the screen. So you see we document the progress as we progress. And the whole thing was done in just 3 days, 28 hours. We still made mistakes, similar to the second time you rode a bike. You know, we still made mistakes, but we improved tremendously from the first time. Now, we also proved last year that we were very competitive. So we actually won this building that you can see here with this very interesting design. Unfortunately, I'm not at liberty to show you how the building looks like. It has actually been made. It's standing in Dubai. It's beautiful, but I can't reveal it because the customer, Emaar, which basically is the Sheikh's right arm in Dubai. That means they are the one that are responsible for the Burj Al Khalifa, the Burj Al Arab, so the tallest building in the world, the 7-star hotel, the Dubai Mall, the marina, everything Emaar is behind. And we were chosen as a supplier to print the first villa. It's beautifully looking, but I can't show it. Hopefully we can show it to you within a couple of months. Now, we also proven that, well, not only buildings are interesting for this technology, it can also be used for other purposes. So here you see the first ever 3D printed concrete windmill tower, which we did for GE, American GE, in cooperation with Lafarge, who delivered the material. And you will notice when we come at the top here, there's no people. Yeah, there's a guy here, he's standing, he's texting to his wife while he's looking at the printer, but that's it. The whole thing is running automatically, and it was a 10-meter tall print, the tallest print in the world so far. Oh, I was supposed to go on. How do I do that? Can you just make it sure it goes on? Yeah. So in November last year, but it's been first revealed this year again because of COVID. They planned to reveal it in March, but then COVID came. Our Belgium customer revealed the first 2D two-story building in Belgium that you see here. Again, made with our technology. So this is the first two-story building ever made in Europe. The interesting thing here was that it was actually printed by students. The customer itself doesn't have any employees. They are educating other people. So we educated students that could print the building. And that shows you that the technology is not more complex than that. Then February this year, we decided to show the world that this is really a reliable technology, which is why that we took it upon ourselves to actually demonstrate each day for 4 days at an exhibition that we could print a small building every day. So every day from 9 to 5, we had the printer there and we were printing a building, a small, very small building, live in front of people. And you can see there was a lot of people. We were really the talk of the town. If you wonder what that funny thing, it looks like an ice bear in the middle of the house is, that was actually the conference organizers that came to us, and they got totally impressed by the way we could give shape to concrete. So they asked us to print their logo. So we did that. Yeah. Next one. Now, this video will show you a little bit more about the details of how the printer work. And I ask you to notice the end of the print head, there are some metal flaps. And you can see the effect of these metal flaps because they were not used on the first layers, but they're used on the top layers. And you can see what that effect is. That actually removes the Michelin sausage look or Michelin tire look that you will have with a round-headed printer. But we have square nozzles and we print with these flaps, and you see how the walls becomes very, very smooth and very neat to look at, lowering the amount of plastering work needed. There was a lot of video shot that day by the spectators. Yeah. Then here in September, our German company Perry revealed that they would also be building a two-story building in Germany. And you see the building coming up here. They chose not to use the flaps. They wanted to have this 3D printed look of the building because the customer felt that would be selling well. Whereas we normally tend to print with the flaps to make it a more smooth wall to look at. I'll show you a picture of how that building is going to look like when it's finished later. So far I've shown you quite small buildings. To give you an idea about the size possible, I'm showing you here a video of the largest construction printer ever sold in the world. And if you notice the small van down in the left-hand corner, it gives you an idea. So this printer is 27 meters long. It is 12 meters across and 10 meters tall. That in essence means that you can print buildings of 300 square meters on 3 levels. That means almost 1,000 square meters in total. This video also shows the robustness, quality, and stability of the printer. This is really a heavy-duty construction equipment that we are selling. This is not a flimsy hobby printer like our competitors are selling, and that's the reason why we're also the best-selling company within this industry. Now, at the bottom, I've shown one of that's in fact Said. No. I've shown one of Said's designs. Sorry, here. Yeah, you can see. And that's actually an office building. It's not been realized yet. Not sure whether it will be, but this is actually a 900 square meters office building. So forget the thing about private houses only. We go for offices, hotels, retail shops, museums, etc. So today, our technology is being used on all major continents. That means we have printers in Asia, we have printers in the Middle East, in Africa, even in Africa. Yes, Africa has actually been one of the two top markets for us this year, Europe and the US. In terms of customers, I think it's noticeable that the large corporations are choosing us. So General Electric, I think I need no further introduction. EMA from Dubai, Perry from Germany, and also various universities worldwide are choosing us. But next to that, we also have quite a few real estate developers that together with architects wants to shortcut the construction chain and do part of what the general contractor normally is doing. And finally, we're also selling into, in essence, our competitors, which is the precast plants, because the precast plants cannot give their concrete special shapes, but we have definitely the capability to do it. Now, to give you some kind of inspiration, I'll show you the amount of buildings that are out there that are 3D printed. And the first thing you'll notice when you see this slide is, wow, is it not more than that? And the answer is no, it is not more than that. But there's been so much BS said about these buildings that it has created a worldwide attention to this technology. So on the one hand, we are fighting a little bit with that people have unrealistic expectations. On the other hand, is also very good because we are discussing with customers all over the world. So it's global interest for this technology. And that is a consequence of these only 20 buildings and the massive false PR that has been made about them. And I'll give you a couple of examples of it in a minute. But let me show you some of the buildings and how they look like as an introduction for Saeed to continue discussing design. So the left one here, the orange building, I'm sure you picked up on that. The video has been downloaded 4 million times because it was claimed that this was printed in 24 hours for a cost less than $10,000. It's nonsense. It took 4 months. And the cost of $10,000, that was only for the concrete itself. It was not for using the printer, for the manning, for the windows and all of that. We actually did a research on 3 years, and the next building, which is in the Philippines, was actually the nicest one that we saw that had been 3D printed. That was 3D printed by a gantry printer, so the same type of printer that we have in the Philippines. And you see, it's actually a quite nice building. So the one on the right-hand side is a Russian building. It's been made as precast components, so 100 different components. Going further on to China, the company Winsun has created a lot of headlines also, and you see 3 of their buildings here, the top right corner showing something else. But the first one was that they showed a picture of this, I don't know what to call it, a small office or whatever, and they said they could print such a building in 1 day, and they had done 10 buildings in 10 days, and they got a lot of headlines on that. Well, in essence, Winsun is a precast plant. They are producing elements in a factory, and what they did in 10 days was to assemble 10 houses in 10 days. That's something completely different than making them. But you can also see that they, with the help of this precast technology that they have, which require a large factory, they also did 1,200 square meter mansion in 2 stories. They did a 5-story high office block, etc. Now the top right-hand corner shows another Chinese project, quite interesting. In fact, the downside of all of these buildings is they're all on the parking lot of the manufacturers. So they're not out there and being used. These are all demo projects that are standing on the parking lot of the manufacturers. Next one. Now, the top left one, I'm sure you've seen, that's the Sheikh in Dubai that came out and said, this is the office of the future and it's been 3D printed in Dubai. Unfortunately, that's not the case. What was actually done was done in China by Winsun, by this precast plant. It was shipped in containers to Dubai, and then Indian and Pakistani workers did all these overhangs that you see and all the nice, interesting architectural details. So what was actually 3D printed was quite simple. You see the bottom left picture, that's a very nice building. In fact, it's done by Apex Core. It's a 650 square meter, 2-story building in Dubai. Nice project. We like it. It looks okay when you are, at least when you're far away. When you get a little closer, it doesn't look that nice. But nice project. Only problem is they spent 11 months on printing that, which is an insane amount of time to spend. On the right-hand side, you see a couple of buildings by Cybe. They're using a robotic arm printer, which has a disadvantage, which clearly you can see here, that in essence, they are printing in elements or in segments, and you have to put these together. So you have to cast them together manually. You also get a lot of thermal cold bridges or heat bridges, because you have concrete touching concrete from the exterior wall to the interior wall. So it's just not the recommended way to use a robotic arm printer. We don't have robotic arm printers. It's not like we don't like them. We think robotic arm printers are fantastic for making, for instance, architectural vases or staircases or other complex columns or so. But for use in buildings, to print an entire building, it doesn't make sense. Move on, please. Now here you see the buildings in Europe, and it's our technology that is behind the 3 top ones. So you see on the top left, you see the BOT building, Europe's first 3D printed building. In the middle, you see the Belgium building, Europe's first 2-story building or 2-floor building. And on the right-hand side, you see how the building of Pieri in Germany is going to look like. But there's been other projects. In France, there's been the Wainova project down there, quite nice looking building. In the middle, you see a Dutch building. Probably you haven't picked up on that before because the customer is not very happy. So this is a private picture that I took. And on the right-hand side, you see a French building, if you can call it that. It more looks like a mushroom to me. Anyway, next slide. And this is what the technological leader of the world can do, North America. It's not really impressive. These are very small buildings. 2 of the ones that you see here, the one in the middle, I'm sure you've seen also. The 2 ones at the left are done in Mexico by the same company called Icon. What is worth to notice is that these are like 60 square meter together, these 2 buildings, and it took them 2 months to print them, even the second time. So they still have some way to go. And then there's a 3rd house on the right-hand side that is coming on stream now. And by this, I will hand over to Said for more information about design.
Yeah, sure. Hello, everyone. As Henrik introduced me, I'm an architect and a sustainable designer over here in Kobat. And I actually help, just a second, I think the presentation is not merged. Just a moment. So I'm gonna take you through a detailed or a quick review of how we actually 3D and design 3D printed buildings. So basically, why, as Henrik just mentioned, the designs of 3D printing have many possibilities. Most likely is the freedom of design and realizing the architectural, let's say, free forms and so on. As architects, we always have this discussion of form follows function or function follows form and so on. And we also have this kind of a challenge of how we can shape the sculptures that we design and so on. And with this technology, we have this advantage of having the freedom of the design without the consequences of weakening or going around extra cost and so on. So this is something that architects believe that this is like a dream going true. Over here, you can see this is the BOT building. As we mentioned before, the freedom of design, we capitalized on that. As you can see here in the plan, there is basically very little straight lines over here. Everything over here is just like waves, and we looked at that and we're inspired by that because this building is near to the sea and it represents the sea or the waves from the sea and so on. I want you to take a notice over here. One of the things that maybe is a misconception or doesn't really come to our minds, that the complexity is actually for free regarding the 3D printed buildings. But again, because this technology doesn't provide the whole building by itself, it only provides parts of the building. So the complex parts of the building will have to be attached with conventional methods. And for example, over here, you can see the roof. The roof has to be cut to match these walls. And at the end of the day, this roof costed 5 times more than a normal roof would cost because it has to follow the complexity of the design. So basically, we have to look about these stuff. So we're getting practical over here and we're talking about what happens in the real life.
So the message here is use the freedom by all means, but don't go bananas because it will cost so much that the client will not do it.
To a certain point, yes. So this is something that you have to consider while you're designing. Again, the architect will be the leader in going through the building process. And of course, when you're designing, you have everything in the back of your head. So I'm trying to show you what you should have in the back of your head when you are designing. So basically, I'm going to go through a general 3D construction printing design guidelines and some case studies that we worked on. So the agenda, I'm going to talk about the freedom of the design. I'm going to talk about the guidelines for 3D printing, about stability, overhangs, corners, and the design basics. And then we will have some kind of a session to evaluate the complex concepts. And then we will go to assembly. So again, this is one of the details that we talked about. This is the bot building, as we mentioned. As you can see also, because 3D printing doesn't provide a whole solution, it provides a part of the building. As you can see over here, you can see the roof. It's made out of wood and steel, and that was one of the major points that increased the cost of the 3D printed building. I'm going to talk about stability. So basically, this is what happens. 3D printed concrete is extremely low in strength and stiffness because it's really fresh when you are printing it. Of course, when you have 3D printed material, it should be pumpable and buildable, and it should have some kind of a layer time. So in that sense, you have to consider what kind of geometry or shape that you want to print and how stable it is. I'm not talking stable as a final product, stable while printing, because while printing concrete is going to be wet and it's not going to be stable. So basically at the right hand side, you can see a stable design because it have a larger base area, and the layer on the left hand side is going to be unstable. Most likely the design on the left can be doable, but it have more tendency to fade, while the design on the right hand side will be more stable, and it will actually be easier to print and so on. The same case goes with overhangs and so on. Right now we're talking about, of course, architects love to go crazy with designs, and because we provide this freedom of design and so on, and we also have to consider the center of gravity and actually how the walls would look like and the overhangs. Basically, we will go or recommend going overhangs by 10 to 20 degrees. Lately, we went up to 30 degrees. It actually depends on the material, on the setting time, on the parameters of printing, so layer width, layer height, and what kind of what's the geometry or the shape of the 3D printed object itself. So, for example, on the right hand side, you can see that there is a counterweight that will keep the center of gravity in base. So actually, this is below, this evenly distributed on the both of the sides, and it's supported by the base. On the right hand side, you can see it's not. So most likely this object would fail into this direction if we didn't have a really fast setting material and so on. This is an example of the overhangs. For example, we had this print, which is over here you can see how much the printing parameters will actually control and provide the stability for the overhangs and so on. So this is a 50 mm layer width and 10 mm layer height, and as you can see over here, it failed at the 30% overhang. We printed the same object, but with a way wider layer width, and you can see it over here. It's around 100 mm with a height of a 10 mm. Basically, if you talk about it engineering-wise or physically-wise, you can see that this area over here will have a better connection, and the force of connecting between both of the layers will overcome the force of the overhang, which is gonna drop it. So basically, you have a better tendency to actually have a stable object. Also, we went slightly crazy with the design and so on, so it was pretty stable using that parameters of printing and so on. We're also going to talk about the corners in theory. So this goes to the design and also to the printing method and so on, because we most likely use square nozzles. So square nozzles also have flaps. Basically, what happens here, if you have a really sharp corner, the nozzle will start etching or removing bit of the concrete from the corner over here, and you will have a really damaged corner, while over here you can have the radius that is much more compliant with the width of the nozzle. So as a rule of thumb, the flap radius should be smaller than the half of the corner of the radius, so you will have a smoother corner. Well, this case only applies when you are using a square nozzle with flaps. If you're using a normal round nozzle, it wouldn't actually care. Basically, you can see it over here. This is a round nozzle. Then you don't have to rotate this nozzle or to actually have the direction of the print itself. Well, it's a different case when you use a square nozzle with flaps, because you have to direct the nozzle to the direction of the print to make sure that the flaps are not actually cutting through what you have printed. So it's easier to print with a round nozzle
It also requires special software and hardware solution to print with square nozzles to get the smooth and the flat walls that we are getting, which is why the majority of the prints that you're seeing actually looks like these sausages that are stacked on top of each other, simply because the other suppliers of this technology, they don't have the solution that we have. So it's easier, but you will end up always with that look then, if you print with round nozzle. We don't care, we can do both.
Exactly, and basically the round nozzle, again, the thing that we also have to talk about, you can see the fair face over here, that we actually can control the nozzle itself. As you've seen these examples over here, we had different nozzles and different thicknesses of nozzles, so we can have a nozzle with 100 mm, a 50 mm, 30 mm, even up to 50 mm. So we can 500 mm, which is almost half a meter, and so on. So these things are controllable, and in that sense, this ability of technology that will help you achieve the design that you can go through. I'm gonna go later on, and I'm gonna talk about what other features that we can do. We also have included in our slides and in our software the ability to add and print patterns and logos. So as you can see over here, we had a map, and our slicer will understand where to move regarding this to achieve this kind of a pattern or kind of a logo. Over here, you're gonna see a video. This video will present how actually we can move and create the pattern. This pattern is generated by a PNG map. You can load it into a slicer, and you can control how much you want to offset through the wall and so on. Again, over here, we're not using flaps, because if you're using flaps, the moment that you are using it, you're gonna eliminate any extrusion or any recess that's gonna happen while you're 3D printing. So I'm gonna talk about also the design basics. So when we design or when we wanna print a 3D printed file, basically we draw the center line, and the center line is gonna be defined by surface. The extruded materials, as you can see it over here, the width of the printed wall will be defined by the nozzle width. And as we talked previously, you can actually change the nozzle width. You have a variety, and you can actually 3D print this nozzle and then use whatever you want, which is whatever services your design. The format can be step file or IGS. So no center line should also have sharp corners if you are using a square nozzle or a rectangular nozzle, and so on. For example, this is how it comes from a CAD file, and then we go through the slicer, and this is how the drawing of the layers would look like. So basically, if you load a file looks like this is how the outcome would happen, or how it would look like. We will have a small example or a study case. This is a model 102. Over here, we can see the slicing settings. So the layer height was 20 mm, the nozzle width was 50 mm. The print speed also defines the material and what's your layer time and so on. And then the travel speed is the actual speed that when you move from an object to an object. When you design something like that, you have also to consider what kind of internal support or structure that you have to provide. So your geometry will be actually physically stable, and depend on the local codes that you're going to use, or depends on the design that you have. Basically, on the left-hand side, you can see that we have the zigzag print or the snake print that will it's like the infill in normal 3D printing. On the right-hand side, you can see these voids that later on will be used as columns to support the wall. This is an example of how that model later on was 3D printed. This is another kind of examples that how you can actually 3D print complex shapes and so on. There's another example over here. It's a kiosk with a unique kind of a design. Over here, we also we have to have these comments about the radius or the limits of the sharp edges. So basically, we talked about this V shape over here, and we have to avoid all of these sharp edges. All the drawings should be represented as a center line for the printed wall and so on. And again, because you have the freedom of design and the printer is already there and can do everything, also consider about printing outside benches, other furniture, frames for windows, and so on. That will be also useful because you already have the tool that is in function at the moment. Here also another examples of how big printers can actually do a lot of buildings at the same time, because we use a gantry system. So when you set up the printer and you have a big printer, as Henrik showed, you can actually have multiple units and have some kind of row units and so on. You can see on the left hand side, there is this 300 square meter printer that can print 3 units. And this is a project that we're working on. And over here, you can see also the same possibilities. Yes, sir.
If you look at the bottom 2 pictures, we think those are examples of more sensible ways of utilizing the form freedom of the 3D printer. Because here we are making some more interesting designs than the top line shows, but it's not going totally bananas, right? Because, you know, organic shapes are nice, but you have to still think about, well, there needs to be a bed and that needs a corner, or a desk that needs a corner, and so on and so forth. But we think the lower examples here on this slide are interesting examples of designs that uses the freedom but doesn't go too bananas.
And over here, we can also see the construction details, or exactly how the 3D printed building would look like. This is more detailed of how the double wall would work. Of course, over here, we have been considering other things that we have to accommodate in our 3D printed design. For example, the insulation, the acoustic properties, the structural system, and so on, to make it as livable as possible and to compete with the conventional methods of doing so. So in that sense, what I'm trying to deliver over here, that 3D printing does not mean, if you're using 3D printing, that you have to compromise what happens in normal buildings. You can do it the same way and even better and faster. As well, this is the same project that we talked about. This is another example of freedom of design. This is also a project that we worked on. Over here, you can see that we utilize the freedom of design to have this kind of a flower-shaped classrooms. And over here, we also went not only for the local of architecture of the same building itself, we utilized how we can arrange it in kind of an urban design, how we can make a school that actually have a protective space in the middle without the using of these ugly fence walls and so on. Also, it will give you some kind of advantages of amphitheater acoustics and so on, and creating a new environmental sense of the educational systems and so on. Again, the freedom of design was used in other projects. You can see the CAPC project over here. As an architect, it's up to you to decide what kind of a feel that the building should have. Some architects, or basically some designers, find value in this 3D printed walls and so on, and they keep it as a statement that this is the method that was used in that building and so on. So let's have a summary about what we talked about. The complex design is possible, but not too complex. Freedom of design is free for 3D printed segments of the building, but not for the non-3D printed attached segments. We talked about that regarding the roof. The size of the printer influences the size of the building, the layer height, the layer width, and so on. This is something that you have to consider, which is the printing parameters that are essential for achieve required design. So we talked about that. So the layer width, the layer height, the nozzle shape and size, using flaps or using no flaps, the printing speed, and so on. Material is a cornerstone in 3D printing, so what is the layer time and the buildability? Also consider structural stability and strength that should be considered in your design. So when you're designing, also have in the back of your head how this building is going to be structurally stable and what kind of strength that you can have in that sense. And basically, this is what...
This was our presentation.
This was our presentation, exactly.
Thank you very much, Henrik. Thank you very much, Zaid. So, guys, don't hesitate to ask your question. Let's benefit from the presence of Henrik and Zaid with us today, and just ask whatever you have in mind.
There are no
and they
questions.
will be happy. Yeah, and they will be happy to answer them. Maybe just from my side, first general question. So you are saying, Henrik, that there are things that are not, let's say, less houses or constructions in 3D printing that we may think today. So at which horizon finally you think that it will become really widely
Well,
adopted
if you look at
construction
really widely
practice.
adopted, you are talking about a massive billion dollar industry, and that in any event will take some time to build up. But we will see starting next year, we will see the first series of buildings being made with the 3D printer. So one after another are on the same site. Some of these real estate developers that we have as customers, they're planning on doing 30, 50, 100, 500 buildings, etc. So I think that's the next step we are going to see. All these one small buildings or larger buildings, one-offs, they're interesting to demonstrate the technology, but from a commercial point of view, it's not that interesting. So I think it will start to become interesting when we do lots of buildings on the same site with the help of the technology, and that will help it to achieve the necessary market share.
Okay.
Thank you, Henrik.
I just
sorry,
saw
Zaid?
a question over here regarding.
Yeah, so we are having another question. So what is your current solution for 3D concrete to resist tension, especially for the slab?
It depends on different ways. You can do it in three methods. The first method is to consider your material itself to be designed to handle the tension. It could be about the chemistry or the mix design, including fibers or including a special kind of concrete. This is the first method. The second method is to have a very stable geometry about the building itself. So the 3D printed object itself have the geometrical properties to hold this tension. The third method is to use a conventional method of adding rebar steel and so on. So that could actually happen.
So 3D printing does not exclude using all the methods that you are normally using, for instance, for reinforcement. So we normally tell our customers that in worst case, we'll have to do it the usual traditional manual way. We like to find ways that are more automatic, that are smarter, that are faster. But in worst case, we can always do as the industry has been doing for 50 years.
We have another question over here.
Thank you. Yeah, another question. So thank you very much for this presentation and the overview of all this construction around the world. The free design argument is very strong for 3D. Isn't it a limitation to the generalization of this technique, only requested for aesthetic aspects and requested by
passionate
architects?
Actually need more passionate architects, because you have the advantage that you come in and discuss with the possible building owners faster than what we do. So the worst thing that you can do with this technology is, in fact, to ask us to copy something that has already been designed in all detail and has been optimized to the conventional technology. Because by asking us to copy that, you're not taking advantage of all the new possibilities that this technology brings. So hence, actually, we definitely are in favor of that architects are becoming way more involved. I can say right now, from a commercial point, what has driven the interest and what is driving the sales of our printers right now are economics. Mainly, it's faster, no labor usage, getting rid of the shortage of skilled labor, which exists in many countries, Japan, the US, Europe. We're seeing fewer and fewer people that wants to be skilled construction workers. By letting the machine do the complex parts, you actually reduce the amount of skilled labor that you need, and thereby overcoming the problem. So I would say right now it's economically driven, but we love it to be more driven by architects that can see the advantages. I mean, we don't know how to do it, to be honest. We are technology people. We are automation people. You guys are the experts. You can figure out, all the nice designs that everybody will love to look at and the smart ways of using the technology. So please knock yourself out and find out a lot of good ways to use this technology.
Thank you, Henrik. So another question. Yes, indeed. Yesterday we had a presentation from Twente Additive Manufacturing regarding the Fibonacci house, and in their presentation they mentioned slicing a crusher step in our design, like designing for a building that was made up by components pre-printed and then assembled. This morning, Henrik, you mentioned that working with components is not the way a 3D printed building should be conceived. So should we only aim for an uninterrupted printing process?
Yes, if you want to achieve the lowest cost. Then definitely this is the recommendable way, because everything you part up into bits, you have to put together again, and that costs money. So that's not advisable. If you can make the whole thing at once, why would you make it in parts and put it together? It doesn't make sense from an economic point of view. However, there are certain solutions where it does make sense. I'll give you an example. If you are repairing a road where there's a manhole or a sewer, it's smarter actually to go in, use a scanner, find out how are the dimensions required, seal off the road again so that traffic can continue, go back to the factory, make the unit, and then put the unit in, the manhole in when it's finished, so that you don't disturb traffic that much. So there are cases where precast makes sense. Could also be for very tall buildings and for slabs and so on, because slabs have the problem, you can't slabs between, let's say, the ground floor and the first floor, you can't print into thin air, right? So, but you could print the slabs on the side of the building and then lift it in.
Another maybe point regarding that on printing of segments, again, because when you are printing and assembling, there's different loads that will happen to the element itself when you carry it and put it in place. So you have to have an extra cost of reinforcing that kind of element when you put it in place, and then you will have an extra cost of connecting these elements and so on. And again, we know that even in precast normal manufacture, you will have the hooks that you have to hoist it. So it's also not designed to be in place when it's in function, and as a building, it's also designed to be carried. So if you can run away from that kind of method, it's also a good thing. Again, you will be wasting a lot of money on transportation and the limitation of transportation, because trucks will not have the big ability to actually transport whatever you want. So printing in place wins in that kind of sense, because you eliminate the possibility of transportation and the limitations, what you can put on a truck and you cannot. And the other point is the connections and the structural design and the cost. Okay.
Thank you very much. So another question regarding printing large overhangs, especially for slabs, except for using temporary support, is there any other solutions?
Yes, of course. I think by overhangs you mean that there's nothing underneath the slab. In essence, there's only like a rim that you can rest it upon. So the smart way of doing that, especially if you have organic shapes, which the precast plants cannot deliver you a slab that you know, is made in with organic shapes, would be to start by, before you print the building, you print the slab. So what you do, you use a printer to print the perimeter of the slab, and then you cast out a little bit with concrete, you put reinforcement in, you cast the whole a little bit more, then when it's hard, you lift it into the building. So it's still, you're still using the technology, and you don't have to do the supports, etc., because you do it on the ground and then you lift it in. You would have to have some Perry casting boards or something like that, but you can actually do it as integrated part of the process itself.
Thank you very much. Thank you again for all this presentation, for your insights and sharing with us your knowledge. Well, we will still have the chance to have you until the end of this challenge. Thank you guys for your questions, and don't hesitate to contact us, to contact Gobod if any other questions may arrive after that. Thank you again, everyone. Bye.
Bye-bye.